Very good evening everyone. I am Satyam Kumar, physics teacher. So welcome to my YouTube channel Satyam Knowledge Bank. Today I am going to teach new topics Lenz law. So be get ready. Okay. So here Lenz law. Now, what is Lenz law? According to Lenz law, induced current will produce in such a direction that it will always opposes the cause which has produced it. It will always opposes, induced current will flow in such a direction that it will always opposes the cause due to which it has produced. Okay, so see. According to Lenz law, induced current will flow in such a direction that it always opposes the cause due to which it has produced. Okay. So see, according to Lenz law, induced current will flow in such a direction that it always opposes the cause due to which it has produced. Now, cause may be anything. It may be due to increasing or decreasing magnetic field. It may be due to increasing area, or due to changes in the angle between area vector and magnetic field. Okay, so see, suppose let us take one more example. Let us take one conducting coil. Okay, when this conducting coil is placed in magnetic field, the magnetic field is perpendicular to the plane of the board and it is inward. Okay, now when a conducting coil is placed in external magnetic field and magnetic field is such that, see, if magnetic field B, which is inward, is increasing, means magnetic field is not uniform, it is changing. With respect to time, magnetic field is changing. So if inward magnetic field is increasing, what will happen? Due to the increasing magnetic field, flux will change. flux will change. Due to the changes in the flux, induced EMF is produced. And if the induced EMF, induced current will also be produced. Induced current will be produced. Okay, see. Now, if the magnetic field inward is increasing, if the magnetic field is increasing, flux, it will change the flux. Flux will change due to the increasing magnetic field. Now, whenever the flux changes, according to Faraday law of electromagnetic induction, induced EMF will be produced, and due to induced EMF, induced current will produce. So, if this magnetic field is increasing, induced current will flow in this conductor, in this conducting coil. Now there are two directions. The current may flow to this direction. Suppose the current flow in this direction. Okay, suppose the current flow in this direction. So what will happen? If the current flow in clockwise direction, then magnetic field, see, current carrying coil produce a magnetic field. One is external magnetic field, one is this external magnetic field which is increasing. Other will be the magnetic field due to induced current. When the current flow through this conducting coil, it will also produce magnetic field. So the magnetic field produced due to this conducting current carrying coil will be, see, if the current flow in this direction, it will be inward. Okay, it will be inward. Magnetic field will be inward. If the current flow in this direction, magnetic field produced due to induced current will be inward. And already external field is inward, and that is increasing. So again what will happen? This magnetic field will increase, it will become more. So which is against the Lenz law. Lenz law states that induced current will oppose the cause. So here what is the cause? Cause is the increasing magnetic field. So induced current will flow in that direction, so that this so that it will oppose the increasing magnetic field. Here, if the current flow in this direction, it will support the external magnetic field, which is not possible. So the current should, according to Lenz law, current should flow in this direction, anti-clockwise. See, if the current flow in anti-clockwise direction, magnetic field due to this current carrying coil will be upward. So this will oppose the increasing magnetic field. This will increase the this will oppose the increasing magnetic field. So magnetic field which is increasing will decrease due to this induced current. This is what? Induced current. Okay. So in this case, so current will flow in anti-clockwise directions. So in this case, if the magnetic field is increasing, induced current will flow in anti-clockwise direction so as to oppose this increasing magnetic field. Okay, now what will happen if this magnetic field is decreasing? That I am going to explain. If this magnetic field is decreasing, external magnetic field is decreasing, you see, you can copy and write. You can copy and write. You can copy and write. Okay, now I am moving ahead. See, if the external magnetic field, which is perpendicular to the plane of board inward, is decreasing, if this magnetic field decreases with time, then what will happen? Due to flux can be changed either by increasing magnetic field or decreasing magnetic field. So what will happen? Flux will change. Flux will change. Again, due to changes in the flux, according to Faraday law of electromagnetic induction, induced EMF will produce. Induced EMF will produce. Okay. Now, if the circuit is closed, then also induced current will be produced. Okay. So, if magnetic field is decreasing, see through figure C, if this conducting coil is placed in external magnetic field which is perpendicular to the plane of this board and acting downward, okay, then if the magnetic field is decreasing, then flux will change, and due to changes in the flux, induced EMF will be produced, and due to induced EMF, induced current will be produced in this. So current will flow in this conducting coil. Now there will be two choices. The current may flow in this direction or in this direction. So if the current flow in anti-clockwise direction, then magnetic field produced due to this induced current will be outward, and again this due to outward magnetic field, this magnetic field will again decrease. It will again decreases. So this is against the law of Lenz law. This is against Lenz law. Okay. So it will oppose the decreasing. Induced current will flow in such a direction so that it will oppose this decreasing magnetic field. Here what is the cause? Cause is the decreasing magnetic field. This is the cause due to which induced current has produced. So it will oppose the decreasing magnetic field. It will not support the decreasing magnetic field. If the current flow in this direction, then it will support the decreasing magnetic field, because again the magnetic field will decrease. It will further decrease. So induced current will not support the decreasing magnetic field. It will oppose the decreasing magnetic field. See, now if the current flow in this direction, if the induced current flow in this direction, then what will happen? See, this then magnetic field due to this this induced current will be what? Inward. So it will be inward. Okay, magnetic field produced due to induced current will be inward if the current flow in clockwise direction. So if the current flow in this clockwise direction, it will oppose this decreasing magnetic field. That is according to the Lenz law. Lenz law states that whatever is the cause, induced current will oppose that cause. So here decreasing magnetic field is the cause, and induced current will flow in such a direction so that it will oppose the decreasing magnetic field. If the current flow in clockwise direction, magnetic field will be inward, and external magnetic field is also inward. But external magnetic field is here not increasing, here it is decreasing. So induced current will flow in clockwise. So see, induced current will flow in clockwise direction, then only it will oppose the decreasing magnetic field. Okay, so in this case, in above case, you can write in above case. So in above example, induced current will flow in clockwise directions. So in this case, induced current will flow in induced current will flow in clockwise directions. Then only it will oppose the decreasing magnetic field. Then only it will oppose the decreasing magnetic field. Okay, I hope you are understanding. Induced current in this case will produce in clockwise direction, then magnetic field will be inward, and in this case magnetic field is decreasing, so it will oppose the decreasing, so there will be less decrease in the magnetic field if the current flow in clockwise direction. If the current flow in anti-clockwise direction, then there will be more decrease in the magnetic field. There will be more decrease in the magnetic field, which is against the Lenz law. So the current will flow in anti-clockwise direction so as to so that it will decrease less. Okay, understood? Now you can write. Now I am moving ahead. See, let us take one more example. See, if suppose this is rectangular coil. Okay, let us take one more example. And magnetic field in this case, external magnetic field is outward, perpendicular to the plane of board, and it is outward. External magnetic field is outward. Now, if the magnetic field, external magnetic field, if the magnetic field which is external, perpendicular to the plane of board and outward is increasing, if it is increasing, then what will happen? flux will change. Due to the increase in the magnetic field, flux will change, and due to the changes in the flux, induced EMF will again induced EMF will be produced. Induced EMF will be produced, and due to induced EMF, induced current will be produced in it. Will be produced in it. Induced current will flow. So if this magnetic field is changing, if this external magnetic field is increasing with respect to time, then here current will flow in this conducting coil. Now there are again two directions. In which direction the current will flow according to Lenz law? Let us see. If the current flow in clockwise direction, if the current, let us suppose the current flow in clockwise direction, then what will happen? See, if the current flow in clockwise direction, then magnetic field, due to this induced current, because current carrying conductor also produce magnetic field, so magnetic field produced due to induced current will be, see, it will be inward. Due to induced current, it will be inward, and this external magnetic field is increasing, outward is increasing, and due to this current, clockwise current, induced current, magnetic field will be inward. So this is correct, because if the magnetic field produced due to this induced current is inward, then this will decrease, this will increase less amount, it will not increase so much. Okay, so induced current will oppose the increasing magnetic field. Induced current will oppose the increasing magnetic field. So this is the right direction, because they are opposing the increasing magnetic field. Here what is the cause? Cause is the increasing magnetic field. Cause is the increasing magnetic field. So induced current will oppose the cause according to the Lenz law. Now if the current flow in this is what? Anti-clockwise. If the current flow in anti-clockwise, then magnetic field produced due to this anti-clockwise current will be outward, and this is external magnetic field is also outward. So it will, magnetic field will again further increase, which is against the Lenz law. So the current will not flow in anti-clockwise direction, it will flow in clockwise direction, so that it will oppose the increasing magnetic field. Okay, so in above diagram, in above example, in above case, you can say induced current will flow in, induced current will flow in clockwise direction, clockwise directions. So this is how we can determine or decide in which direction the induced current should flow. So Lenz law, through Lenz law we can determine or decide the direction of induced current due to the changes in the magnetic flux according to the according to the Faraday law of electromagnetic induction. Okay, let's take one more example of Lenz law. See, this is conducting coil and this is magnet. When this magnet will move toward this conducting coil, what will happen? More magnetic field lines will pass through this conducting coil. So there will be changes in the magnetic flux. There will be increase in the magnetic flux. So due to increase in the magnetic flux, induced EMF will produce in this conducting coil, and hence induced current will produce. Now in which direction induced current will flow in this conducting coil? So see, So induced current will produce in such a direction so that this surface of the conducting coil behave as north pole, so that this north surface and this north pole both repel each other, means it will oppose the coming magnet. This surface oppose the coming magnet. Okay, this will repel the coming magnet. So this surface will behave as what? North pole. This surface will behave as north pole. So in this, the current will flow in anti-clockwise direction. Current will flow in anti-clockwise direction, so that this surface behave as north pole, and this north pole repel each other. Okay, now we take another example. See, so see, current will flow in anti-clockwise directions. Current will flow in anti-clockwise direction. Okay, current will flow in anti-clockwise directions in this coil, because the magnet is coming toward the conducting coil. So this induced current will flow in such a direction so that it will oppose the increasing magnetic flux. So this side will behave as north pole, and this north pole both repel each other. So they will oppose, this coil will oppose the incoming, or this will repel the incoming magnet. Okay, now another example. See, if in this case, if this is our conducting coil 1, and if this magnet going away from, if this magnet is moving away from this coil, if this magnet move away from this coil, then what will happen? Magnetic field lines passing through this surface, this coil will decrease. So magnetic flux will decrease. Due to decrease in the magnetic flux, induced EMF will be produced, and due to decrease in the magnetic flux, induced EMF will produce, and hence induced current will produce in the conducting coil. Now this surface, the induced current will flow in such a direction that so that this surface behave as south pole and north pole both attract each other. So this coil will attract the moving magnet. Okay, this is what our magnet. So this surface of the coil will behave as south pole, so that this south and north both attract each other, and they will oppose moving away the magnet. Okay, so in this case the current flow in clockwise direction. Current will flow in clockwise direction, so that this will oppose the decrease in the magnetic flux. So in this way we can say that Lenz law works, and in this way induced current flow in any conductor. Induced current always opposes the cause which has produced it. Okay.